Since our 2D shell mesh has now been established, the stringer and frame lines of the model can be used to create the inner structure of the fuselage in the form of beam elements. In HyperWorks, there are two methods of performing this. One method involves using the metadata embedded in the lines. To view this metadata, we can click on the Post ribbon and select Matrix. Once the Matrix browser has been opened, we can populate this browser with the metadata by selecting HMData, Modules, and pressing Query. Following this, we can select the lines in the graphics window that contain our metadata. The selection below displays that 4 parts have been selected. This represents the 4 different parts that the lines are organized in. By pressing the green check mark, the part IDs of our lines will appear in the Matrix browser. If we click Modules above, several options will appear in the Data Names window. From this window, we can select Metadata. In the following window, we can select Beam Section Dimension and Beam Section Shape, and press Query. After this, the Matrix browser will populate with the dimension and shape metadata contained in the stringer and frame lines. This can be utilized to automatically apply these properties to the inner structure of the fuselage. However, another method of establishing these beam sections is to manually input these properties. To do this, we can select the GFEM Builder ribbon, select the Stiffener Mesh tool, press Create, and ensure that Lines is chosen from the drop-down menu. Following this, we can isolate one of the parts select them, and ensure that Orient Normal to Shell is selected. Making sure that the From Metadata on CAD checkbox is unchecked, the desired properties can be added manually by selecting Beam Section, right-clicking, and selecting Create Beam Section. With this window, we can create a T-shaped beam section that is identical to the one shown in the metadata. We can change the name, select T from the section type, and define the dimensions with respect to the reference image. Press Close and click the green check mark. The T-shaped beam elements have been added in the lower region of the fuselage. This same procedure can be followed to define the remaining stringers and frames. For this demo, however, I have already created the remaining beam sections manually, and will select them using the Advanced Selection window. Although the added beam elements are one-dimensional, the geometry that they represent can be seen by changing the viewing settings. At this stage, this geometry is only graphical, but can be used to determine the orientation and offset that the beam elements represent. If we open the Stiffener Mesh tool, click Orient, and change the drop-down menu to select our elements, we can use the toolbar to rotate our selected beam sections. We can rotate our beam sections by positive 90 degrees, negative 90 degrees, and can orient our beam section along the normal of the fuselage shell mesh. Similarly, by using offset, we can change the position of the beam sections with respect to the shell mesh. By isolating the different parts of the line assembly, we can see the different geometries of the beam sections along with their offsets and orientations. Through automation, it is possible to create all the beam sections from the existing metadata and associate them to each part. To show this, we will delete the existing beam elements and recreate them by reading the metadata established in the CAD. In this automation process, the dimension and shape metadata is used to automatically create the beam section in HyperWorks. This newly created beam section is then linked to the part. Now, we can once again select the Stiffener Mesh tool, select Create, and select all of the stringer and frame lines. By leaving the From Metadata on CAD checkbox selected and pressing the green checkmark, all of the beam sections can be created automatically without having to manually define these properties. Through changing the viewing settings, we can see that the beam elements have been created as desired through using the metadata. Additionally, these beam sections can be edited in the Matrix browser. By selecting HM Data, Beam Sections, and Query, we can select the 4 beam sections in our model that are shown in the graphics window. We can then select dimensions 1, 2, 3, and 4, which are the dimensions that pertain to the beam sections. Pressing Query with these dimensions selected will display them in the window above. By changing the dimensions in this window, the dimensions of the beam in the graphics window will update in real time. Finally, these 1D beam elements can be transformed into a 2D shell mesh alongside the mesh of the fuselage. To do this, we first need to make the fuselage the current selection. Then, select the Create Shell Mesh from Beam Elements tool and select the beam elements. This micro dialog box can be used to define the element size and type. In this case, we will use an element size of 10 and set the type to quad. By pressing the arrow, the 2D shell mesh is now created for the interior of the fuselage. The purpose of this is to create a detailed FE model that can be used for a number of applications, such as determining connector quality or performing buckling or fastener analysis. In addition to the mesh, the surfaces of the stringers and frames are also created. This allows for editing or exporting to CAD for further refinement.